Hello, welcome. Gosh, that sounds a little quiet. Can you hear me at the back? Yeah? Good, good, good. Come on, chop, chop. In you come, quick, quick, quick. Run, faster. You're going to have to find a seat now. Right here. No one wants that seat. So thank you very much for choosing to come and hear me talk about Distribu-ready and the Modular Monolith. My name's Layla. I'm an unemployed bum. I don't do anything. I do a bit of game development on Twitch these days, hanging out, coming to conferences, preaching about modular monoliths. And that's what we're going to talk about today. Yay! Alrighty. There we go. I was checking it works. So there is a content warning. Every conference talk needs a content warning. There is a lot of weird AI-generated imagery in here. I take no responsibility. I may have given it the prompts, but, you know, it does its own thing. It's magic. So it does get weird and a little bit creepy, so please don't be scared. It's not real. It's all make-believe. So I'm going to start this with a quote, because I really like the idea behind this quote from Sir Richard Branson. Complexity is your enemy. Any fool can make something complicated. It is hard to keep things simple. Now, as developers, we always want to try the newest, greatest, bleeding edge thing. We want to do what might look good on our resume, or we come to events like this and you see people like me telling you about all these new things and you're like, I should be doing that. I need to be doing that or else I'm not keeping up. I'm not going to be able to get that job. That's all well and good. Knowing that these things exist and are out there is very different from going back and implementing them on your project. You need to think really hard before you go and do that. I feel quite passionate about this. I had a job once. And my lead developer on that team was a little bit of an experimenter. And I tell you this because it's relevant to this quote. And I was going through the APIs, and we were in our sprint planning, and there was this one particular API out of hundreds of APIs, endpoints this is, and I said, why is this one using Hateos? It's a type of API structure that's very complicated, and we didn't do it. We did regular REST. And he goes, oh, I felt like trying it out and seeing how it worked. I was like, right, so why is it still in here? Oh, well, like, yeah, I tried it out. And I said, you didn't think to do this in a spike? I guess I should have done it. OK, so now all of us, every time we go near that API, have to manage that. So he added complexity just for trying it out. So don't do that. Come here, learn all the things, but then don't go and try them out. Don't necessarily try out modular monoliths, OK? You might be tempted to, but, you know that they're a possibility. I'm not telling you go home now and start doing this. So I need to stress that, because there's a lot of hype around this type of technology right now with things like Aspire. We'll get to that. OK, so let's have a little chat about what this is. We have a monolith, what most of us start with. Sorry, this antenna is really tickly. I'm going to have to put it in my pocket. There we go. So most of us start with a monolith. That's that big rock on its own. And then we might dream of a distributed system. That's a cluster of them at the back. I mean, I think that's not completely distributed. There's some connecting stones there. I'd say that might be going towards badness there. That doesn't look quite so isolated, because those sarsen stones are coupled. We don't like coupling. No. So that is kind of the idea. You see this imagery a lot, and you'll hear a lot of people preaching about go distributed, do that, do this. So what exactly do these technologies mean? So most of you should be familiar with what a monolith is, and that's a traditional approach. You have a single executable Everything's quite easy. The debugging process is lovely because you can just follow the code paths. Everything's encapsulated. It's all there. You don't have security issues. You don't have all this communication stuff. It's just nice to work on, nice to deploy. But you do have issues of scaling, and some people say difficult to maintain. I don't think so. Depends how well they're written and maintained before you touch them. So they're a good place to be. Then we have microservices architecture or distributed architecture. And this is where you have lots of individual services all doing their thing, and they should all be independent. They all communicate with each other through various different methods. They're easy to scale. They're easy to maintain. They're really difficult to work with. They are difficult to develop in your at-home environment. People are going to tell you, Aspire makes it easy. So if you're not familiar, Aspire just went GA a couple of weeks ago, and it's a very opinionated stack for managing your distributed workloads or whatever workloads you have. So people are going to be telling you that microservices are easy because we now have Aspire to make it easy. That is a lie. Microservices are not easy. No matter what tools you have to help you, they are not easy. And you just need to remember that as I go through and tell you all the things I'm going to tell you. So you're thinking, what might I need to be doing with my big monolith? Or maybe your CTO is out on the golf course with another CTO and boasting about, oh, we have a microservices architecture, and your CTO is going, oh, damn it, we don't. Yeah, we're going to implement that. Oh, are you? Well, okay. And he comes back, or she comes back and says to you, yes, right, team, we're going to have a microservices architecture. And the 5 of you go, we are? But there's 5 of us. No, we need it. And so that's another thing. You don't want to have CTO-driven development. So we've already spoken about resume-driven development. Definitely don't want CTO-driven development. And I'll say something now, and I really stand by this. If you ask yourself the question, do I need microservices architecture? If you cannot definitively say, yes, by gosh, I do, then you don't need it, okay? So I want you to bear that in mind as we go through this, because it's going to help you. And that might change, but at this moment, if you can't say, yes, we need it, you don't, all right? Okay, so why might you need it if you needed it? Well, you want to scale and meet your growing business demands. So you may think you only have 2 options. You've got your current monolith. You could scale the entire app. That would be vertically by giving it more compute, or horizontally by multiple instances. You could go and look at where the bottlenecks are and maybe refactor a bit of code here and there and make it a little bit better. Or you have the other option that you seem to be presented, which is distributed systems. And you break up your app into individual services that can all scale independently. It's magic. It all works. It's amazing. You're running ahead. Great. So what actually is the difference if we compare these 2 types of architecture? Well, Monolith is really easy to develop locally because, like I mentioned earlier, you just put a breakpoint, you hit play, and off it goes. Microservices, you may need containers, you may need all this other stuff that supports it, and that can be difficult to run. Your environment may be different from your teammates' environment. It may be different from what's on production. It's a really hard thing to do, and that's one thing that Aspire does try to solve for you, okay? So that bit isn't a lie, okay? So that makes life a bit easier, but it's still really difficult. Updating and maintaining monoliths, well, you're coupled. You can't just do your bit, which might have a dependency on someone else's backlog item, and then deploy. You might be like, well, I need to coordinate with that person who's going to do an update, and then we'll deploy it. If you're working on a microservices architecture, you can make your changes and deploy like 20 minutes later to your service, completely independent of another service. And that's kind of the dream they sell you. You can deploy multiple times a day, and certainly you can. So scaling and growing them is different. As we mentioned, you can scale the monolith by more compute or more instances. But with microservices, you can just scale one of those services. So let's say you have a notification service, and it's going to send out emails. When you're doing a bulk email sort of transaction, you can scale to multiple instances of that and then scale back to 0 when you've finished it. So that's nice. It's cost saving in that aspect. Deployment, you could right-click, publish your monolith. Yay, nice and easy. But with the deployment of distributed systems, that's more complex. There's a lot of orchestration that needs to happen around that. All right, so that decision sounds straightforward. Yeah, you need to scale. You're going to go to distributed microservices. However, microservices come at a cost. If that wasn't obvious with all my stuff that I've been saying on the way here, then they come at a cost. And that is simplicity. You've now made your application so much more complex. It's not great, is it? You're having to have all these different things. You've got containers for this, containers for that. Everything has to work together. It's infinitely more complex. I cannot stress that enough. So let's say you do need to go distributed. What does that journey look like? Well, if we go to this chart, which I stole off an ex-teammate who stole it off someone else, but as I always say, this is mine now. I own this. It's on my slides. It's my chart. We have distribution versus modularization. You've got your monolith, and you want to go to microservices. Straight path. Yeah, right. This is probably where you're going to end up. The distributed monolith. Okay. That is not a good place to be. Now, you might dabble with the distributed monolith on your way to your distributed services, but generally, you want to avoid this little guy as much as possible. I think he looks really cuddly. And if he came over my desk, I'd be like, I'd count my fingers afterwards. But, you know, he seems quite cute and cuddly to me. What could be wrong with that? Let's see what exactly is a distributed monolith. Because a lot of people go, ooh, the distributed monolith, or the distributed big ball of mud. That's even worse. Yikes. So what exactly is it? Let's take this diagram. As developers, we like to do stuff with code. So we might delve in and start divvying up our code into different services, and then we look at the database and go, yeah, I don't know how to decompose this data into 2 databases, and now we'll have to get our services updating. Who owns the data? Then there's that weird thing, eventual consistency. Well, that sounds like a recipe for disaster. Well, I'm not going to go into that. That's for a microservices talk. But you're left with this. You have 2 services sharing a database, or any kind of service, all right? And you're like, what's wrong with that? Well, let's take the idea that you need to do a migration on your database to serve one of your services. Okay, so you've done that, you've deployed that. What about that service? That now has to be updated in order for it to work with this updated database. And what you've actually done is coupled your services via the database. You can't independently deploy your database and your application as one without dragging the other application along with you. This is the worst possible situation to be in, okay? This is where you do not want to be, because you have all of the complexity of a distributed system, like all of that horrific local development stuff and all the coordinating and monitoring and all that stuff. but you have none of the benefits of independent, discrete services because you've just coupled them. You also don't have any of the ease of monolithic development and debugging. This is just a really, really awful place to be. And it is so common. Now, what we want to maintain as a golden rule when we're approaching all of this is loose coupling and high cohesion. This is something you'll hear bandied around in DDD a lot and domain-driven design, but this has been around for a lot longer, and this is something that you should always have in the back of your mind. And we'll come back to that a little bit more in a little bit. So this is our golden rule that we need to keep in our heads as we move forward. So what is the right way to go to a distributed system? What would be lovely and rosy and make you all smile, and especially that CTO on the golf course? All right. So this is what we had going to that distributed monolith. And what we can do instead is go via a modular monolith. And then, if you need to, you can go to your distributed architecture after that, completely avoiding the distributed monolith. It's not strictly true, but you're in a lot better place if you go this route rather than trying to go directly to microservices. And then I had to include this meme because you don't want to be this sad little dude on the left-hand side there with his distributed monolith. You want to be the happy guy with his modular monolith. I'm painting a lovely picture here, aren't I? It's wonderful. OK, so we'll go back to this chart now. And this is what we want to do. And now we have this third option that we didn't have before. And doesn't it sound like the best of both worlds? Yeah? Yeah? Sounds great, doesn't it? It has a lot of the problems of both. Yay! Oh, you thought I was going to give you the golden bullet, didn't you? No, 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 no. OK, so what exactly is a modular monolith? So it is a piece of software architecture that is monolithic. So we have a single executable, and then everything within inside it is divided into modules. Technically interchangeable, if you're probably not going to interchange them, but everything is tightly modularized. Now, this allows for improved maintainability and scalability within a single runtime environment. And I'm going to tell you why it can do that as we go. But that's the gist of it. It's a monolith that's very modularized. Now, I'd like to introduce you to the KitKat pattern. Yay, yay, a new pattern. We always want to learn a pattern, OK? And I'm going to ask you now, I know there's at least someone over there, I can just see you, who is going to disappoint me. Who eats a Kit Kat like that? Yes, I mean, this is your Kit Kat picture. Jody over there sent me this. Monsters. You're monsters. Who eats their Kit Kat like this? Nothing other than monsters. You should break a finger off. OK? Now, why have I called this thing I'm going to tell you about the Kit Kat pattern? Well, I want you to think about your monolith like an entire Kit Kat bar. Each module is wafers, and it's encapsulated in chocolate, and it's one big bar. They're all completely encapsulated, and you can snap one off, can't you? And, that's a module. You could swap that out for a, I don't know, dark orange, chocolate orange Kit Kat finger, or, oh, my personal favorite, matcha. You could swap those modules out, and you'd still have the same looking thing. It's modularized, and you've got these Kit Kat fingers. So how does this work in my application, or your application, our applications? This is your plain old monolith. We've got a data access layer, we've got the logic, we've got our API. And I don't care if you've got other types of architecture, whatever the latest whizzy thing is, you know, they've all got weird names. I don't care. You can apply this to whatever architecture you're using, just sort of translate it over. So we're going to stick with N-tier because I feel most people will be familiar with N-tier. All right, so we want to slice everything up vertically. So now we've got, in this case, 3 distinct modules, each with an API, the logic, and their data access layer. You may believe that this is vertical slice architecture, but that's different. That is taking a feature and doing it all in that sort of slice, all of the different parts of the feature in one module. That can be applied to distributed architecture, monolithic architecture. It's not the same thing, and I highly recommend you go see my friend Chris Sainty's talk on Friday at 11:40 in room 3 to learn about his journey into vertical slice if you want to learn more, okay? So that's a similar ideas, but it's definitely not the same. So you may be wondering, how do we go about decomposing the application into these modules? Because it's very easy for me to say, yeah, just slice it up into 3. We go back to that golden rule. We have loose coupling and high cohesion. And this really is a core design principle to keep in the front of your mind, all right? You won't get very far without this. So what exactly does this mean? Well, if you've got things that are all very similar, they're doing the same sort of thing, they have high cohesion. If you've got lots of things that are disparate and don't really have much to do with each other, you could say that they are loosely coupled. And in the case of our code, we should be able to do stuff in one module without impacting another module. And that defines that it's loosely coupled. Now, those things in the module should be very cohesive. They should be tightly related to each other. So with our cohesion versus coupling, we want to think about how similar and things are in a module. Are they all working on the same sort of area? And coupling is that interdependence between things. So things inside a module can be coupled, but we definitely don't want coupling across modules. Now, if it has unrelated elements inside it, you're going to be in trouble as well. You don't want low cohesion in your module, because that seems a bit pointless. Now your module's doing more than one thing. I like to think of this as macro single responsibility principle, okay? I like my solid principles. I like to bring those in. So if you think about a module having that single responsibility to something, you can start applying solid on a macro scale. I quite like that. You may not, but I do. And it's my talk, so it goes. Okay, so my recommendation is you start incrementally with the largest chunks possible. Don't just go diving into your code. Gather yourselves around and get a whiteboard or a blank wall or a Miro board, get some Post-its, virtual or real, and then start thinking, well, where are the areas that are highly cohesive? Start grouping things. Start thinking about, well, all of this is to do with orders. Don't worry about getting too granular. Keep it big and orders, inventory, notifications, dispatch, like I've done here. All those big chunks, because it's a process. You're going to do it in nice big chunks, and then, if you need to, you can decompose further. So in this case, our orders module can be broken down into further modules. Whether your other modules need to know about those submodules, oh, that's a design decision, but they may not need to know about those. So you can start breaking things down further and further. But you don't want to get too small, because then it's too granular, and that's a problem as well. So it needs to be just right. You can see where the complexity comes in, right? OK. So I've spoken about code and modules, but what about that pesky database? Well, we have two options. We've got code first, and then we have database first. So let's look at code first. As developers, I mentioned earlier, we're like, yay, let's go divvy up the code, extract that out. Excuse me. So we take that code out, and then that might be fairly easy. That's generally the easier way to go about it. And then we're left with the data in the monolith. That may or may not be easy to separate. And if you can't separate it easily to support your module, you may be faced with bringing that module back in, recomposing, is that a word? I don't know, re-amalgamating it back into your monolith and thinking again. So if you think your data is going to be pesky, more pesky than your code, you should go data first. So this is where you start to separate out your data, tease it out, and then you've got your separate data, and now you can go and get your module out, OK? And that might be a lot easier. I think it probably will be once you've got there, but you need to know and think about what your module is going to do so that you can get your data out. And if you're going with this kind of architecture, you need to forget about dry, don't repeat yourself. Especially if you're going distributed, you need to repeat yourself. Because the number one question I get asked about when people are doing distributed architecture is, do I really need separate data stores? Yes. I will die up here and say, yes, you absolutely need a data store per service. You cannot share this stuff. It is a big no-no, massive no-no. I will hunt you down. I will drag you up here and die with you, OK? You cannot do that. You must separate it. However, you may not go to a distributed system. So you may just stay here with your module and your monolith and your shared database. That's OK. It's all right. I said it's OK. I won't come and hunt you down. Do we actually need to decompose the data? That's what you need to ask yourself. How likely are you going to go distributed? How much of a bind is sharing this data going to cause you? You really need to be pragmatic, not dogmatic. But there is a golden rule, another golden rule. I've got quite a few of those. You need to know that you have accrued a technical debt. Because you've got that data still coupled, it's still in the one database, and you've got modules sharing it, if in the future you do go distributed, you have a technical debt to go and separate that data. Because remember, I will hunt you down if you don't, so you have to do it. But it's just understanding where your technical debt is being accrued. That's the longest. So how is this Distribu-ready, the title of this talk? How can we go and make this distributed if we require it? Well, remember my KitKat pattern, that very last point. A finger can be broken off. What did I just do? Oh, there. I nearly dropped it, that's all. A finger can be broken off and is in itself a self-contained chocolate bar, just like a module in your application. So you can take one of those modules out, and now it should be completely encapsulated, completely able to stand on its own. So DHH came up with the Citadel pattern. I don't like that. It doesn't make sense to me. So, I have yet another new pattern for you, the satellite pattern. This makes so much more sense to me. We have a central, maybe modular monolith with self-contained modules that can be broken off and become satellites. One of my favorite uses of this with your monolith is Azure Functions. So remember that notification service I mentioned earlier, hypothetically? You may want that to be an Azure function, and you have that as a supporting satellite to your monolith, so you're partially distributed. And when you need to send out 1 billion emails, you scale that Azure function up, or your Lambda, whatever you're using, or your standalone application in a Docker container, and then you scale it back down to 0 when you need to it. So things like long-running processes and things that take a while and are volumetric, no, that's about fog in game development, not that, are flabby and long-running processes could become these satellites to support your monolith, taking the load out of your main application and into these other workloads. So you can just carve off a satellite from your modular monolith. That's why it's a bit Distribu-ready. And those can go. They can be standalone apps because of the way we architect them, the way we think about them. And they can be containerized, serverless, and then they can scale independently. So that is the key. And this is one of the reasons why you may want to go down the distributed monolith route. Now, on our path to distributed, this means that you can incrementally go distributed. As you start to monitor, you need monitoring, you need health check, you need to know what's going on in your application, you need to know where the bottlenecks are in the load. You can take that particular module, extract it out of your monolith, and then deploy it independently. Scale it as needed, and now you've made this more scalable. If that needs lots of work and maintenance, you can deploy and edit and do all of that independently of your main monolith, but we're not all the way distributed. And I think this is a really good place for a lot of applications. You don't need to go all the way over to distributed straight away. You can just have this sort of halfway house if you architect your systems properly. Which leads me on to an important question. How do we do this? We have some things that we have to think about first. How do we ensure the modules remain completely independent? This is really key, because if they are not independent, we can't carve them off and deploy them independently, because we've got some coupling somewhere. We've made a big boo-boo. So how do we ensure they remain completely independent? How are these modules going to communicate with each other? Because we've got these clear boundaries now. They're encapsulated. But our code probably still needs to talk to other modules. So how are we going to go about doing that? And this is a big one. How do we enforce that architecture? That is something that is part of the culture that you need to start adopting, because our applications are around for quite a long time. How many of you work on an application whose architect has already left or moved on to another project? Yeah, I bet a lot of you, all right? Unless they documented their vision for the original architecture and your onboarding is great and all of these other things, you may not understand the direction the code and the application was going to go to. So how is that architecture, that original vision, being enforced? Now, to demonstrate this, I'm going to introduce you to Taki Tacos. I've been working on Taki Tacos for about 4 years. It's been a distributed application, and then now in its most recent guise is a modular monolith, and I use it in my workshops. And that's where I've got all this architecture. Now, I learned a lot of this when I wasn't unemployed, and I worked at VMware, and I worked with our enterprise architects. I worked with massive companies that use this architecture, and I worked with them to distill all this information to you, and I speak to a lot of people about it. So if we want to take a look at the modular architecture of Taki Tacos, this is what it looks like. And we're going to delve into this so you have an understanding of how you might apply the things I've told you about to your application. Things to note with that architecture is that we have a web API layer. Let me just go back there. You see we've got a web API. Discard the client. That could be on a CDN. That's probably some JavaScript-y rubbish off somewhere, you know, none of that. Maybe Blazor. I don't know. I don't care about that. It's off. It can be scaled, whatever. We're not really worried about that. We're interested in the web API. Now, that is our executable. That's the glue that binds everything together. Then we have our logic layer that sits underneath that, and that's where all of our modules sit. And they are going to abide by strict intercommunication rules set out in a contract. See, we're getting very forceful with our language now. So we have a lot of projects within this monolith. And that's because the way that we can enforce modularity in .NET is with our assemblies, our csproj files, okay? So we have all of these projects. And you can see that web API is the glue across them. So we've got orders, orders tests, and then we've got orders.contracts. That's a class library. In fact, just about all of these are class libraries except the web API. You could have them as executables if you want and just ignore the executable. Some might say that when you come to carve it off into a distributable, that it's all ready to go. Yeah, I think you could be tempted to do bad things. So I like to keep them as class libraries to really cement that our web API is the executable. OK, so our web API project references our modules. It is the only project that is allowed to reference modules. It's the glue, remember. It can reference those directly. Module project references are only contracts. They cannot do module to module. These are my rules. Yours might be different, but I recommend something like this. Our modules can only reference the contracts. So how do they communicate? Now that we've got these rules laid out, well, external communication, let's start there. That's easy. So this is coming from our client through to our web API. Well, we can have that RESTful or whatever flavor of that you wish. And we'll have a request come through from the client to our web API. And then the web API will direct that request through to the endpoints. Because it's encapsulated, our endpoints are in the modules. So that's going to go through. And then we might have some other ones. You know, it could be posts, whatever, and it's going to our different modules. And the web API handles all of that. Now, in our module, we'll have something that maybe looks like this. So this is minimal APIs, and we've got some extension methods for web application, for example. So this is like an example of how you might wish to do it. So we've got all of these, and then in our web API, well, we've got some other stuff here, other endpoints. We bring those together. But where we go. We've got module service collections. OK, so this is all still, let me come back here. So this is extending web application. So this is for our endpoints. If you look at there, I've brought all of those map order endpoints together into one add order endpoints. That could be because you have some other app stuff you want to bring in, some other middleware. And then we go to service collection, because our web API has to create the dependencies that our module requires. So if you have a dependency in your service on another service, inside your module this is, so you've got another service has a dependency on this service, and you need to inject that into your constructor, well, who's going to create that instance of that dependency. It has to be your web API. So we need to create all of these dependencies and add them to our iService collection. But we don't want to just grab all of those and do them in our web API program.cs. So we, again, use these extension methods to encapsulate them all there. And we have this public method that says, hey, just go and call this add orders and in the web API, and then it will go and create all the instances that you require of whatever lifecycle you need in your application. So if we head on over to our web API, we have all the places that we bring our code in. So if we take here, a look here, let me see, how am I going to do this? This is all our dependencies that we're calling from our modules. So we've got order modules, payment module, and menu module. And this is going to bring all of its dependencies. And we're going to add those to our IOC container, our inversion of control container. So we've got a nice bit of dependency injection here. And now that is available. All those instances are ready for our modules to use. Okay? So we have to do it this way. And then if we come down here, you can see we've added all of our endpoints. So we've got our menu, order, and payment endpoints. And anything else that you need to add per module is all encapsulated in those extension methods. So this is why our web API needs to reference our modules, because it needs to bring all of these things through and instantiate them and add them to the web application. So that seems quite straightforward. Those are our endpoints. And then if we were to carve off a module, we've already got those endpoints there. So all we need to do is add in a program.cs, change the CS proj to be an executable, and then call those extension methods in our module program.cs. So it's ready to go with minimal updates to it. So that's key. Inter-module communication is where it gets even more complicated. Lots of people who have come to this talk or come to my workshop go, this is what we do. Fine, that's your decision. You can make a direct call between your modules. You can give them public interfaces so that they can talk to each other. I don't personally like this approach because you've coupled those modules to each other, and when you come to carve them off, you're going to have to do something with that, okay? You're going to have to uncouple those, decouple, that's a better word, because this is what you've got. You've got them all linked and talking to each other, and I think you've just made more work for yourself. But if you do go this approach, that's okay. Just remember you have technical debt accrued by it, okay? That at some later date, you are going to have to come across and decouple all of that. So rather than direct calls, we can come and do something like a mediator pattern. Okay, so this is where we have that mediator. I'm not talking about like Jimmy Bogart's mediator with all the vowels missing. That is a tool that you can use, but it's pretty straightforward to be able to create your own mediator. And this means that your modules are encapsulated. They talk through this mediator, and as you remove them out, they're not coupled to each other. So this is a really nice way of going, that you've decoupled them, you haven't got a dependency between the modules. And this also leads you on to another way of doing it if you need to. So you may start with a mediator, but then you might want to go to messaging. So messaging here, this is a simple diagram of it. We have a producer that's creating a message. So this is things like queues and pub subs and all that kind of stuff. And we can enqueue a message onto a message queue, and then the other module that needs to know about that message can dequeue it. So this is what it looks like. will send a message to our message broker from the orders, for example, and then the kitchen will listen for the message it's interested in, dequeue that, and do whatever it needs to do. So this has decreased coupling greatly. And that looks really similar to that pattern, doesn't it? Very similar. So you can start with your mediator and then go on to a messaging type architecture. This type of thing is sometimes called event-driven or message-driven architecture. So if you want to learn more about that, you need to go see that man's talks and courses, Ian Cooper over there. He does a lot with this. He is the all-knowing godfather of message-driven stuff, okay? So go and see some of his stuff. But things to note, remember our web API is our glue. It's that single layer. So everything, like our producers and consumers, need to be registered inside the web API. That's something that might catch you out. You have to put everything in there. That's the executable. That's what runs it. And people go, you can use messaging in a monolith? Yes, you can. Totally. I just want to touch on types of messages, because in the next diagram, I'm going to show you how Taki Tacos uses it. There are thin messages, which are the type of event thing. It's like an ID and a status. So you're saying, hey, yeah, this order ID is paid. It's this, it's that. So they are very small, only enough information to update all the services that are listening to them. Then we have fat messages. I didn't name this. There are some other names for it. But they contain a lot of information. They might contain all of the order details. And a lot of services or modules might not be interested in all that data, so it's a little bit wasteful. If they don't need that data, why are you sending it? So how do you get that data if you're not sending it? Well, let me come here and show you this. This is an example using RabbitMQ, which is my favorite message broker. And this is a topic exchange. So this is complex, but it shows how you can implement it. Remember, it's complexity. So we start with an API call to the order endpoint, and that returns an order ID. And then we make a call to the payment module and say, hey, can you take payment on this order ID? And you might just send it the amount and the details to take the payment. So now we've got this order over in the order module that is got a status, like is it paid, unpaid, whatever. And then we have, I don't know what's going on down there. Then we have the payment service, and it's going to send out a little message and say, hey, this order is paid, or maybe it's not paid. So it's going to send that out. And you can see there's its little key. That's called a routing key. You don't need to worry about that. But that's how other services can pick up the message. So it's going to say, order ID, this is paid. Now, if we go over to the order, it's listening for orders.update.anything. It's got a wildcard on it. So now that order is paid, but what else is listening to it? We have our kitchen. It's listening for orders.update.paid so that it can start cooking. But it doesn't know what's in that order, so what's it going to cook? Well, this is where we can do a fat message. First of all, we ask for that order details request with the order ID. So we've got the order listening out for that request. So the kitchen says, hey, orders, can I have the details of this order ID? And then orders will say, yes, of course, and it will publish a message with all the data that's needed. Now, it won't have like payment details or anything like that. It's just going to say, hey, 5 extra meaty tacos, hold the guacamole. Okay, so it's going to send that off. And that's how that system can start to work and communicate. Okay, we have now drastically increased the complexity of the system, and that's why you need to go and learn more about this type of architecture. You need to understand all the things that you have to consider. Error handling, implementation details, just the whole thing is vastly more complex. Yes, it's robust. It's a great architecture, especially for volume, and it's very resilient. It's fantastic, but it comes at a big cost. Okay, so our modules are now loosely coupled and easier to convert to satellites, because we can just pluck one of those modules out into a satellite, and it will still continue chatting, more or less, to our message broker, and it's all fine and dandy. So how do we prevent the inevitable? That big ball of mud looming just behind you, ready to go. And this is something that you have to be very, very strict on. There are several ways that you can enforce architecture. We're going to look at these. So we've got code review, compile time, automated tests, and a style guide. Code review, I'm going to include pair programming here. There are issues with pair programming in this context. I love pair programming. I think it's super effective. It's a great way of sharing knowledge and challenging the status quo. It's a fantastic tool. However, for enforcing architecture, the person you're pairing with needs to be intimately familiar with the architecture. They need to be able to identify, oh, actually, you shouldn't do that. We've already got another system over here. We don't want to link those. That would be coupling. You're supposed to do it this way. So they need to understand the architecture, and they may not. Also, it's quite slow. It's time-consuming. And if you're pair programming, it's much better to spend that time developing new things and sharing ideas than looking at architecture and making sure that you haven't messed it up. But code review is always valid. Go and have a look at it. Make sure, yeah, this looks right. But we don't want to rely only on that. So that leads us to compile time. And this is achieved through encapsulation. That's why we've got so many projects, all those different assemblies. And we want to adopt private by default. So that's our accessors on our code. Each module should be a distinct project or assembly and use the internal accessor, and only make it public if it absolutely needs to be public, like those extension methods that the web API needed to use. Now, some of you are going to go, but we can use reflection. We can use that .NET 8 unsafe accessor. We can get round your private and internal and all of that. Well, then you're idiots. That's fine. Go and do that. Know that you're breaking the rules. I mean, yeah, it's there to make the compiler go, no, sorry, you shouldn't be doing this. If you then choose to go and do that anyway, well, that's your problem, not the code. So that's why it's very valid. OK, so remember this. We've got all of our nice little tests. This is how it looks when we, not tests, projects. This is how our encapsulation looks. We've got all of our internal classes, and then we might have public classes on the outside, and then we've got these contracts. And now you may be going, well, I'm not quite sure what this contracts is. What is that? But they're basically like DTOs, data transfer objects. It's enabling modules to understand what they're receiving from other modules. It's saying, this is the data that I'm giving you, and apply it there. So let's take this example. We're going to send an order DTO through our message broker, and then our kitchen module knows what an order DTO is because it's got access to the contract, and then it can convert it to whatever it needs to, okay? So this is our way of communicating. It's our bounded context between things. They know what they're sharing, and you can be specific about the data that the kitchen module receives, because you're not sending an entity, you're sending a DTO, so you can be very prescriptive. OK, so moving on to, with the compile time, we get immediate feedback because we get errors in the compiler. So you need your code to actually conform to the architecture. If you've been lazy and you've got public everywhere, well, you're not going to get errors when you try to access a method or service that you shouldn't. And it can be circumnavigated, and it's undocumented. Then we can have automated tests. So we've got static code analysis tools, which are pretty cool, and architecture tests. Now, these static code analysis tools, I find that such a mouthful. They're automated, self-documented. They do reporting. They integrate with your IDEs, your CI/CD pipeline. They are like I think they're YAML. They might not be. You can define them, share them, reuse them, so you can really define them. They can detect all sorts of things. So they can improve the quality of your code, and you can set this up to suit your project. Architecture tests, they are automated, self-documenting. You get good feedback. They're just like unit tests, but for your architecture. They do take time and discipline to implement, like any type of testing. You're going to need good coverage. You have to go and put the tests in for them to be effective. And we don't always have the time. There are business pressures. This is an example of an architecture test if you're interested. So you can be very descriptive what should and shouldn't be able to communicate with other things and what assemblies should be able to talk to each other. Then we have a style guide. Benefits, it's documented, yay! We love documentation for onboarding. When you get new people, they can read the documentation and go, oh, okay, I know what I'm supposed to do now. It is a resource. It's really great. Now, if you're unsure about starting your own, Google has their style guide publicly available, so you can go and take that and adapt it to your own needs. Okay. So to summarize the modular monolith, use the modularity where you need it. Okay? If you don't need to go down the path of a modular monolith and you're fine with your monolith, then stay there, because as soon as you start going to these more complicated architecture, you are introducing a lot more complexities. You have to be really on the ball maintaining these things, because you will have the overhead of managing and deploying these things, or you don't want the overhead of managing and deploying these microservices, okay? So it's a halfway house, but it will get you there. So the key things to remember is be pragmatic, not dogmatic, okay? That should be a given in all aspects of your code. Be aware of the technical debt, because everything you do, or don't do, more to the point, is going to give you technical debt that you will have to go and deal with at a later date. And remember that other golden rule, high cohesion and loose coupling. So I've spoken about this quite a few times at the beginning of it. Can you use .NET Aspire in a modular monolith? Yes, you can. It's actually really well suited to it, because you can start your message broker with one click. You can have your web API start, your client start. You can have any satellites start. So it's a really nice environment to work with your modular monolith. It's great. So yes, go and have a play with it. I have quite a few YouTube videos on some of the things I've spoken about. So there's things on architecture tests and messaging and all sorts of things on there. Solid if you need a recap. So go and check it out. If you want to hear more of my thoughts on modular monolith and how not to get into a distributed architecture, I've got a nice talk on .NET Rocks. Go and listen to that. I talk more about why I'm not into distributed systems. And with that, I'm going to say thank you. I'm streaming a lot on Twitch at the moment, doing game development in Unity, so if you're interested in that, you can go there. And I also want to say thanks to Dream Studio for all the weird art. Apparently, I look like some kind of demonic fairy thing, slightly frightening. And if you have questions, I'm going to be from 3 o'clock on the JetBrains booth. That's the word I'm wanting. So you can come and have a chat to me over there. I'll be there answering your questions. But yeah, thank you so much for giving me your time, and have a great rest of your conference.